Good morning, everyone. Thank you for joining us on this webinar on arrays in tag-based. The presentation itself is roughly about 20 minutes. We'll go straight into that, and if you have any questions, we'll get to those at the end.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we are looking at arrays in Cscape tag-based, or what we call variable-based advanced ladder. First, we'll show what are arrays, and then we'll compare arrays and structures. Those are two similar but different features that people often get confused. Then we'll cover different examples of arrays and when you might use them. Then we'll look at arrays of structures, which is a great way of utilizing arrays and structures together to get the most out of both features. Finally, we'll look at two-dimensional and three-dimensional arrays in addition to single-dimensional arrays. We'll have demonstrations throughout, and as always, we'll finish with a Q&A session. So, what are arrays? By definition, an array is a variable that represents a collection of data all of the same type. Arrays can come in multiple dimensions. For a one-dimensional array, you can think of that like a list. A two-dimensional array is like a table, and a three-dimensional array you can think of like a Rubik's Cube. Arrays, along with structures and UDFBs, are three of the most compelling features with variable-based advanced ladder in Cscape. Now let's look at how arrays work in Cscape. As mentioned in the last slide, arrays are variables. So like any other variable, you need to create and assign a name to an array, as well as assign a type, whether that's Boolean, integer, etc. Here I'm showing an example array called sensor, which I have typed as Boolean. Then with arrays we need to assign a dimension to the variable, which is what makes it an array. So in the example on the screen, we have a one-dimensional array with a dimension of 4, meaning there's 4 elements in the array. And then when you type that dimension of 4 in the program variable window, Cscape will display it as an index of 0 through an index of 3. That's because indexes in Cscape are 0-based. The index is the element within the square brackets that allows you to specify which of the pieces of data within that array you're talking about. Now let's compare arrays and structures, as they're very similar but different. So both arrays and structures can assist you in organizing your data. Arrays are variables themselves, so you would directly reference arrays in function blocks, screen objects, etc. Whereas structures define a custom type. When you create a structure, you're creating a custom type, and then to access it, you need to create variables that use that custom type or use that structure. That's the key difference. With arrays, all the elements within the array have to be the same type, whereas with structures, you can mix and match different data types, which is an advantage of using structures. Then you can also have arrays of structured variables, which is effectively taking advantage of the best parts of both arrays and structures. Next, let's look at some examples of one-dimensional arrays. One-dimensional arrays are the most common arrays that you can use in your application. One example of a one-dimensional array would be an array that represents 8 temperatures in a multi-zone oven in a heating application. There's an example of what that looks like on the right called zone temp, which is an array of the real type that has 8 different elements with an index of 0 to 7. Another example could be a material handling application where you have packages moving on a conveyor belt and multiple locations. You could create an array based on a Boolean variable with 256 different elements to it. Then by examining the individual elements within that array, you could see which areas on the conveyor have packages and which ones don't. Now let's talk about some arrays that are predefined in the Cscape variable-based advanced ladder. Those are located in the global variables section of the program variable window that basically map real-world I/O memory locations over to a basic array that can be used for configuring remote I/O. You can see some of those listed on the right. Now let's look at how you create arrays in Cscape. Like creating any other variable in Cscape, you start from the program variables window and then go to either the global variables section or the retained variables section, depending on which area you want to create that variable in. Then you need to assign a name to the variable and give it a type. Then if you don't do anything else, you've created a regular variable, but by going to the dimensions column and by adding in a value greater than 1, you've now created an array. So in that dimension column, you can put in as many elements as you want. Now, once I've created a variable array, how do I use that in Cscape? First, an individual array element works like any variable which you can tie to function blocks, screen objects, etc. In this example, I've tied this object to the fifth element of that array that has an index of 4. One question we get quite often is, can I access the index as a separate variable? For variable-based advanced ladder, you cannot directly access the index as a separate variable, with one exception that we'll cover shortly. You can do that in structured text, which is one of the Cscape IEC languages, but again, in variable-based advanced ladder, it's not an option. Now, here's that exception that I talked about, which is using the indirect move function block. You may be familiar with the indirect move function block in register-based logic. However, in variable-based logic, it's almost exclusively used with arrays. The indirect move function block allows you to move data from a source that's either not definitive or not a fixed location to a variable that is a fixed location, or to move data from a variable that's in a fixed location to an array that has a variable location to it, or both the source and the destination can be variables. Let's look at an example on the screen. Here we have an array called RTD temperature, which is listed as the source for an indirect move. Now, why is it listed as the source? Well, somewhere within that RTD temperature array, we'll grab data from one of the elements of the array and move it, in this case, to a fixed location to a variable called RTD display data. Now, which of the locations in the RTD temperature array are we going to pull that data from? Well, that depends on the index or the offset. Once we configure this function block and say that we're in the indirect mode for the source, the offset field becomes available for us to assign any variable that we choose to be referenced as the offset. In this case, I have a variable called RTD display index. So essentially, the OCS at runtime will read the offset variable RTD display index and say, for example, if it had a value of 5, then it's going to go to RTD temperature index 5 and copy that data over to the fixed variable of RTD display value. So in this case, you have the ability to access the index as a separate variable, which can be convenient. It's important to note that anytime you're using an array as either the source or the destination of the indirect move block, you always reference the first element in the array, which is why we have RTD temperature 0 as the source, even though we may not always be pulling from the 0 element. Now, let's begin our demonstration where we'll look at using arrays in Cscape. So first, I'll start off simple. I'll go to my global variables, and at the very bottom I created a simple array variable called safety sensors. That's a Boolean type and it has a dimension of 4, so it's showing an index of 0 to 3. The way I use that in my logic is that these 4 safety sensors are each connected to inputs 1 through 4 in my program. So that's why I've put this array in my global variable section, because that's where I'll typically put any variables that need to be mapped to real-world I/O. So in the memory column here, I'll put %I1 because I want the safety sensors starting at index 0 to be mapped from I1 through I4. Then I've put them in series. And if all of the safety sensors are on, it means my OK to run contact will turn on. Then if any of the 4 safety sensors is off, then my OK to run contact will turn off. Now let's look at how we might monitor this on a screen. So I'll go into the graphics editor. Here is my first screen that has the safety sensors on it. I have 4 indicators and each indicator is tied to one of the safety sensors. I'll go into the configuration. Here we reference the variable like you would with any normal variable, except we also have to put the index for the array element. In this case, we're looking at the first element of the safety sensor array. That's index 0, so this indicator is tied to 0. Then this sensor 2 is tied to index 1, then 3 to index 2, 4 to index 3, etc. In the legend for each of these objects, I also put the index down, just so that it's clear for the sake of this demonstration. Now let's look at that on the OCS. So here is my program, and here I have sensor number 1, which has an index of 0, which is currently off, which is preventing our OK coil from being on. Now I'll turn that on using my I/O simulator, and you can see that OK to run signal turns on, and when I turn off my other sensors, that turns off again. So that was a quick demonstration of a very simple array. Now let's go back to Cscape. In this next example, we have a series of RTDs. I'll scroll down to my retained variables section to the RTD temperature variable, which is configured as an array for real type values, and it has 10 elements in it. This isn't data directly coming in from the analog input RTDs, it's been converted over to floating point value in temperature. Now I'll go to the graphics editor. So let's say in this application we want to give the operator the ability to type in the temperature zone that they want to monitor. So those zones are 1 through 10, and then based on the number of the zone that they type in, the appropriate temperature value will be pulled from the array and displayed on the screen. Again, for demonstration purposes, I'm showing the index or the offset for the array. So if I want to look at zone 5, I need an index or an offset of 4, because the fifth element has an index of 4. Now let's look at the logic behind that. Here we used an indirect move function. First, we need to calculate what our offset or index is going to be when we execute the indirect move. In this case, we have zone 1 through zone 10, corresponding to an offset or an index of 0 through 9. So we simply need to subtract 1 from the zone that the operator wants to look at. Temperature 0 is referenced as the source address because, again, the source is going to vary, and we always reference the first element in the array when it's going to vary as either the source or the destination. We've configured our mode as indirect because we're going to pull from different locations depending on what zone the operator wants to see. Then our offset will be pulled from the RTD display index variable. Then we'll copy the temperature we are pulling from our array over to RTD display value, which is displaying on our screen. Let's look at that on the OCS. Here is our screen, which is currently displaying the last zone that the operator looked at, which was zone 2. I'll change that now to zone 5. You can see that the logic calculated an index or offset of 4 and pulled the temperature for index 4 from the array and displayed that on the screen. So as we change to different zone numbers, our offset or index changes as appropriate, and we pull the appropriate data from the array and display it on the screen. Now let's look at arrays of structures. Remember, arrays are just variables that you can directly access, and that you can give multiple elements by assigning a dimension to them, but all those elements have to be the same type, whereas structures are the definition of a custom data type. Let's look at an example. So here we have a user-defined structure called motor param, which we created to define motor parameters. It has 4 variables stored within it: current, which is a real; voltage, which is an integer; horsepower or HP, which is a real; and RPM, which is an integer. There's different ways we could use this. Let's say we have a few different motors in our application. Remember, we can't access the motor param structure directly as a variable, as it's not a variable, it's a variable type. So we have to create variables that use that type in order to take advantage of it. So here we can, for example, create variables for our different motors such as main motor, fan motor, pump motor, etc., and assign them the type motor param. We could also just assign or create a generic variable called motor, make it an array, and define it as type motor param. So now if we assigned it a size of 8, for example, we could have motor 0 through motor 7, each of which have current, voltage, horsepower, and RPM stored within it. Now how would we actually access the data within the motor array? Well, if we wanted to look at the data from motor 3, which is the 4th motor in the list, we would write it as follows for each of our different parameters. Next, let's look at 2 and 3-dimensional arrays. I would advise that you only use 2 and 3D arrays where they make sense. Looking again at our visualization that we have for arrays, 1D arrays are like a list, while 2D arrays are like a table, and 3D arrays are a bit like a Rubik's Cube. Now let's look at an example where we could use a two-dimensional array. Here is a layout of a warehouse that is set up with a 3x3 bay type layout, where in each of those 3x3 sections of the building we have a temperature sensor, and we want to store those temperature values in a 3x3 array. Since it's a 3x3 array, that means the indexes for both dimensions are going to be between 0 and 2, as you can see in the diagram. One question you might have is, how does the offset work in a 2D or 3D array? You may think that if you have a two-dimensional array as your source or destination, that you need an offset or index type variable for each dimension. But that is not how it works, and there's still just a single offset even if you have a two-dimensional or three-dimensional array. Instead, the offset counts up from 0 for the first element all the way up to the size of the array minus 1 for the last element. So on the diagram on the right, I've also notated what the offset would be for each of those 9 members of that two-dimensional array. So with the 2D array, your offset is just going to go to a larger number. Now let's look at that 2D array in Cscape. Here are my retained variables, and you can see I've created a two-dimensional array called motor specs. This is a 5x2 array where every element is an integer value. In this demonstration, we'll be showing you how you can access elements with these 2D arrays. Now let's look at how we set that up in the graphics editor. On this screen, we are showing simultaneously all 10 integer values that are stored within this 5x2 array, starting at 0, 0, then 0, 1, 1, 0, 1, 1, etc. And each of these data fields is tied to the appropriate element in the two-dimensional array. In my actual application, for demonstrative purposes, what we're doing is that when function key 1 is pressed, we'll clear all the values stored in the two-dimensional array. When function key 2 is pressed, we'll set them with some predetermined values. Let's look at that in logic. So here my logic says that on either the first scan or whenever I press function key 1, I'll use the fill instruction to copy a 0 to the entire array. To do that, I referenced the 0, 0 index, and then my count is 10. So it's going from 0, 0 all the way through all 10 elements of the array, copying that value of 0. Then, when I press function key 2, I'll call a subroutine that will assign a predetermined value to each element in the array. I've decided to write our values between 100 and 109. One way to assign those values is by using a loop. We'll go through this loop 10 times, and each time we'll assign a value to one of the elements in the array. When we first call this subroutine, we'll assign a 0 to our offset, which will vary between 0 and 9 as we navigate our way through the array. I started out with a value of 0, then I calculate the value that I want to write to the elements in this time of going through the loop. Again, in this case, I predetermined the value I'll write to each individual element as 100 plus the offset. So I calculate that here first, and then I use that indirect move function again. But this time, instead of my source being indirect, my destination is indirect. So again, I reference the first element of the array. I select indirect, and then I'll assign some variable to the offset field. Here I've assigned a variable that I've called offset. I'll write one word because I'm only writing to one element at a time here. So then again I write that value somewhere between 100 and 109 as I go through the loop, and then I add 1 to my offset. Then I check to see if it has a value of 9 or less, and if it does, we jump back to the start of the loop and run it again. We're going to run that a total of 9 times, and when we're done, our offset value is going to be bigger than 9, so we fall out of the loop and we return from the subroutine. Now let's look at that quickly on the OCS. Here you can see my 10 elements of my motor specs array, and they're currently cleared. I'll press F2 and see if those values right. Remember, when I press and hold F2, I'm executing that subroutine, which is writing those predetermined values based on my program to those array elements. Now I'll try using my clear function, and that worked. That concludes our demonstration for today. Thank you for joining me for today's tutorial, and the Q&A session will begin shortly.
Okay, hopefully that was of benefit to you. Next week is using shift registers, and the registration is there on the webinar part of the website. Other than that, thank you all for joining us today, and we hope to see you again next week. Goodbye.